Hey and welcome, my name is Paul Estevez, and in this Houdini tutorial, we're going to talk about time offsetting in Houdini. This is a topic that gets asked all the time, and I had a lot of confusion trying to figure this out. So I'd like to show you my best practices and things I've learned along the way, and hopefully we can demystify this topic. We'll start off with using fully Houdini, no external plugins, just Houdini of how we can set up this time offsetting. And then I'm going to move further along and replace some of the nodes and show you my preferred method using MOPs and how much easier it is with no VEX needed to make these things work. So let's dive in and take a look. So here in Houdini, I have created some flowers, and over here, I just have some rendering containers. So if I turn these off, you can see nothing will be rendering. So I have some stems, I have a little bit of hair, and then I have the flowers, which we need to still create. And so we'll create these flowers and they'll be merged into here. And so inside this container here is where I'll be doing all my working. And inside here, I have the stems. And what I've done is I've blasted off these points, and I've got these points here. These points have normals so that the flowers are pointing in the right direction based on the stems. And I have a file node here, which has the flower that I created. And this flower, if you're interested in how I made it, I created a Patreon tutorial on this last month. So you can go have a look at this. So I bought this animation in here, and at the moment it's set to load in all the geometry. So you can see it's got all the geometry and it's quite heavy. So what I'm going to do is change this to packed disk sequence. And what this allows us to do is to write an index attribute that will change the time of each of these as we go. So this is what's going to kind of unlock the ability for us to time offset this. I've also set this to clamp, and what this is going to do is it's going to clamp it to this frame range. So when it hits frame 120, it will just hold frame 120 rather than cycling. So you have other modes here where you can cycle, and this will just keep looping this around and around. So when it gets to frame 120, the animation will start again, which I obviously don't want. So I want it to start on frame 1 and end on frame 120 and hold on each of those frames. The next thing I'm going to do is I'm going to create a copy to points. And I'm just going to copy this geometry onto these points. Jump back into my camera, and there we go. We have this, and these are packed disk sequences. So it has the animation. If you have a look here, they're opening and they're moving. So it's doing exactly what we want so far, except that we have no offset in animation. So let's look at how we can set that up. Obviously, we need to create some sort of fall off so that we can tell the flowers how we want them to be offset in time. Usually I'd use MOPs for this, but as we're not using MOPs just yet, we'll use a mask from geometry. And this is just going to let us create a fall off that will move through this mesh. And I'm going to run it over the points and create a box. And this box is going to be our driver. So let's just move this into place. I'll set some keyframes on frame 1, and on frame 120, I will just keyframe this to encapsulate all those points. And if we visualize this mask attribute, you can see, if we look at the geometry spreadsheet, at mask, there's still some that are being affected. So we'll just move this back a bit until this is completely 0. Right, so now it's 0, and eventually they are all 1 after 120-ish frames. This doesn't need to be perfect for now. This is just a demonstration. I'll show you how you get some slightly nicer, more organic fall-offs a little bit later. So if we pipe that into here and we visualize this mask attribute, sometimes Houdini doesn't really like showing it in the viewport, so that doesn't always work. And that's one of the downsides of working with packed primitives or packed disk sequences. It doesn't always show you your attributes. So now we have a fall off, and it's giving us this mask attribute. And so now we need to use this mask attribute to do something. And the way that I like to use this is I like to use this mask attribute to trigger a age attribute or a growth attribute of some sort that I'll then use to drive the growth of each flower. So the way that I like to set this up is to create a trigger attribute. And so I'm going to create an attribute wrangle. And this attribute wrangle is going to be to initialize. So init, and I'm going to call this trigger. So this is going to be like the trigger attribute. And for this, I'm just going to call trigger equals -1. And this is just going to give all the points a -1. So this is kind of like its initial state. The next thing I want to use is use a solver. And the reason I'm going to use a solver is so that I can gather the information over time. And this is going to be to add an age attribute. If we dive in here, we need an attribute copy, and we need an attribute wrangle. The attribute copy, I want to copy this mask attribute so that it's bringing in this mask attribute each frame. And I also want to bring in the P attribute. And so if we have a look now, all that this is doing is it's bringing in the points so that they move, and it's updating the mask attribute here. You'll see that if we don't do this, it doesn't bring in any of the animation or the mask attribute from the previous frame. The next thing I'm going to add it into this, and this is just going to be to add age attribute. And the way that we're going to do this is we're going to set it up with an if statement. We're going to say if our mask is greater than a value, and in this case, I'm just going to say 0.5, then we need something to happen. And in this case, I want it to just increment age. So we can say age plus plus. And what that's going to do is once this mask passes this point past 0.5, an age attribute is going to be created. Here we go. You can see that age is now incremented. And I created this initial trigger, and I'm actually going to change this to age. So I want age to be -1 until it gets triggered. So it's -1, and then when it gets triggered, it starts from frame 0, and then it counts upwards. So that's great. But still, this isn't actually affecting our flowers at all. So we need to do something with this. And this is where it gets a little bit more nerdy. And we're going to use an attribute wrangle. And we're going to make this one purple. And this is going to be called set primintrinsic. And the reason that this gets a bit nerdy is that we need to now set the primintrinsic of each of these flowers. So first thing we want to do is we want to just create a driver. And this is just going to be our age attribute that we've already created. And then we're going to use this driver or this age, whatever you want to call it, trigger to set primintrinsic. And if we have a look at the help card on this one, we need a geo handle. So we know that that's 0. We need the name. And in this case, we want to affect the index. This is a built-in primintrinsic attribute that's on each of these packed disk sequences, this index value. So we're not creating this, we're just writing to an already inbuilt attribute. I'm then going to use ptnum, and then we need to use the value. And the value is going to be this driver that we created here with age. And finally, we're going to set it. And just like that, now if we close this, we should start to see something. Let me just refresh my viewport. Sometimes the viewport is not a big fan of showing you what's going on. Sometimes if you refresh it, now you can see these are opening and this one is closed. And it's trying its best to update for us. And you get these weird viewport bugs, but you can see that it is actually working. So this is great. Now, you would think that, okay, we've got these packed disk sequences and we can render them out. So I'm going to plug them into my render out null, and that's going to bring it in over here. So far looking good. And because these are packed, we want to instance SOP level packed primitives. And we save. And if I hit render, you can see that it's no longer doing what we hope. It's not respecting the index attribute. And the reason for that is that Redshift doesn't adhere to or doesn't respect this index. It doesn't allow for that. So these are all going to open at the same time. Even though in the viewport it looks right, Redshift with this checkbox turned on is wrong. So that leaves us with two options. One, we can uncheck this, which what Redshift will then do is it'll unpack this at render time, which in this scene, it may be okay because there aren't that many flowers, but it'll still get quite heavy because it has to still unpack all this geometry, load it onto the graphics card and then render it. And of course we could also unpack it here and then it will work. But again, it will get quite heavy. So let me unpack and let's see if we can actually make this work. Okay, I think that's worked. And that's getting a lot heavier, but let's hit render. You can see that the render times are now a lot slower. It's taking a lot longer to load it in, but now it's respecting. This one's open, this one's closed. So this is what we would want and this is what we would need, but it's really slow. So what are our alternatives? Well, we can delete this unpack. We don't want to unpack it. The next thing we can do is we can turn this into a Redshift proxy. So what that means is instead of bringing in this flower, we're going to bring in a Redshift proxy. So we can use another attribute wrangle, and this is to set rs proxy. And there's a few different ways that you can do this as well. What we're going to do is use this wrangle to render our Redshift proxy, but we're going to reference in our index attribute from our original file node. So I'm going to plug this into my points. So now I'm just seeing points, and I'm actually going to use this as like a reference because I can still read in this index attribute to drive my RS proxies. Now we have to write this whole thing out. So I'm going to create a path, and this is going to be a channel string. We'll just call this a path. And the next thing we need to do is create this index. Again, I'm just going to call it index, but in this case, it's not actually the index that Redshift will read. And I'm just going to read the index attribute from the previous stream. So I'm now reading this primintrinsic from over here. So I'm just reading it into this wrangle. And now I need to clamp these values just like we did in this file node up here. Because we're going to be reading in a Redshift proxy, we don't have those clamp functions. So I just need to write it in myself. So I'm going to clamp the index value to be 1 and 120. And finally, Redshift uses this s@instancefile method. And so what this does is it needs you to give it a path with the right data. So first I'm going to use my path, and I'm then going to add in this sprintf. And this just formats a string like printf, but returns a result as a string. So this lets me create a string, which in another word is kind of like a file path, and I can tell it what it needs to be. So I'm going to use a dot, because that's part of my filing name. And then when I use this percentage sign, it means it's going to replace this percentage sign with whatever I put after this comma right now. So now I can use this index attribute like this, and it's going to replace this here with this index attribute. And we know that this index attribute is going to be correct over here because we can see it in the viewport with this. So when we read it in, it's going to change my frame number per point for my RS proxies. So now I can create this path, and because I don't have a little clicker button here, I can go into my edit parameter interface and change this to be file directory accept. And now I can go and grab my RS proxy, and I know my file is called flower. So I've got flower, and then it's going to add a dot, and then it's going to add the frame number at the end. And I need to also add in dot RS so that it's going to give the frame number in RS, which is how my file is formatted. So now if I plug this into my render flowers, we don't see anything in the viewport because you don't visualize RS proxies, but you can visualize it with this. And we're referencing exactly the same flower with exactly the same offset. And that's one of the reasons that I like this method, is that you can still see something in the viewport with that. And when we hit render, now we get the files. And what's really cool with this method is that it's really fast because they RS proxies, they load almost instantly. So they all closed. And these are opening, this one's still closed. And eventually they all open. So this method is working. So far, we have beautiful offsets and we're getting something going. The next thing I want to do is I want to do something a little bit easier with my falloff so that I can drive my falloffs a little bit easier. And MOPs has a MOPs shape falloff, which could easily replace this. But I actually really like to use the MOPs spread falloff. And this is kind of like an infection solver. There are many other ways to do infection solvers. I just love using MOPs. I find it really fast and easy to use. So here I can just select the point. I can preview my falloff, and you can see that now I've got this cool growth. And I can just animate this from 0 to 120. And in less than 10 seconds, I have this cool falloff, and I can very easily add some noise into this so that as it's growing, it's not super uniform, but rather it starts to break up a little bit more. So maybe just something like this, and I'm good to go. So the only thing I need to do now is I need to change this to mask, or I need to change everything else. And in this case, I can just go up here. Instead of calling it MOPs, I can just say mask. And now I can just remove these and I get a MOPs falloff, and everything else should continue to work. And let me just stop previewing the falloff. So these are open, this one's still closed, and it's a really fun and easy way to create falloffs. So I really enjoy using that. The next thing MOPs has, and this is a MOPs Plus node, so it is paid, but I really like it. It replaces this clunky thing here. It's called the MOPs trigger falloff. And what we can do here is instead of MOPs, we can just change that to mask and mask. And I can plug this in over here. And this will do exactly what we did over here, but instead it'll do it all in this really simple interface, and it has a whole bunch of extra controls. And you can output these attributes. And in this case, we want this elapsed attribute. And so instead of age, I'm just going to change this to elapsed. And again, it's going to be exactly the same thing. The only difference here is it's greater than 0.1. So I can change it to 0.5, and now it should be exactly the same as what we had before. So you can see now these ones are growing, this one's still closed, it's working perfectly. I haven't had to use any VEX so far, just 2 nodes, falloff, MOPs trigger, and we're good to go. And again, I can plug this in over here. And if I hit render here, it's working perfectly. And my materials are doing something weird, but it's working. This one's closed, this one's open, and these ones are slowly opening. Of course, you don't have to use Redshift proxy in this way. You can also just put Redshift proxy directly in here. And in that case, what we need to do now, instead of this over here, we just need to change this to be f at elapsed. And it actually needs to be +1 because elapsed is from 0. And yeah, now it's working again. But now the downside of this method is that even though it works in Redshift, you don't see anything in the viewport and you have no way of visualizing what these points are doing or what Redshift is doing. So I tend not to use this very often, but it is a way if you want to you can create a visualizer like this and then just write it out to proxies in this way using the same elapsed from MOPs. So moving along in our quest to get rid of VEX and to make this even simpler, MOPs has another node, and this is one of the free MOPs nodes, is the MOPs set sequence time. And this basically replaces this node here. So instead of setting the primintrinsic, this node does this for us. So if we open this up, we can change this from expression to attribute, and we can change this attribute to the elapsed attribute that was created over here. And there we go, just like that. You can already see it updated over here. This one's open, this one's closed. Let's just refresh the cache from the solver. Yeah, so this is working really well. And we no longer need this set primintrinsic node anymore because this is doing it for us. But now we run into the same problem that we had before where Redshift doesn't like these packed disk sequences. And so we need to either unpack it or write it to proxies. Of course, we could just plug this into here and we can still read in the index attribute. It's writing out the index attribute for us. So this is working. Great, perfect. So that does work. So you can keep going. But again, we want to get rid of this code, make our lives really simple, really easy. So how do we do that? There is a pack, Redshift pack proxy. So we can now grab the same flower file and we're going to pipe it into here. $f4.rs. So now we have this. And the cool thing with this packed proxy is it actually shows you something here. You can actually see the Redshift proxy. This is a Redshift proxy, but it's kind of like a packed geometry, but a proxy. So I can jump back in here. And now I have my Redshift proxy. And the great thing with this MOP set sequence time is that it actually will work on Redshift proxies. So if I plug this now into here, so we're bypassing all this VEX, right? We're just going straight in here, no VEX. And if we hit play or render, you can see it's working, kind of. But now we're getting this like weird thing where these ones are not even here. And the reason for, remember, is we set these clamp functions on our file node. This doesn't have that ability, but we can set it in the MOPs set sequence time. We can just set both of these on, clamp this, and from 1 to 120. And now they're in here. And we get exactly the same thing where these ones are opening and this one is closed. And we can go all the way to the end. And you'll notice now we're getting an error because we over frame 120. So this doesn't exist. So we can use a time shift node. And we can just clamp both back and front, delete these channels, frame 1 to 120. And now it's working again. There we go. So now it's doing what we need it to do. So these are closed. And you can see the difference in the viewport. Sometimes the viewport doesn't show what is actually happening
whereas the Redshift is showing. And this is really fast because these are RS proxies. And my materials are super weird. I'm not sure how they broke, but they are broken. The other great thing with this setup is that we can set it up like any other copy to points with variants. And so we can have multiple flowers and this whole setup will continue to work. Whereas with this RS proxy method, we're just reading in the index attribute. We're not reading in variants. So we would have to write out a whole variant list and workflow, which I find a little bit tedious and I prefer not to do that. So let me quickly set that up. So now I have 3 different flowers from 3 different proxies and I can merge these all. Then I can use an enumerate SOP and I can set a variant attribute on each of these points because these basically are just 3 points or 3 packed primitives. And here I can use a variant attribute and you can use an attribute from pieces, but I like to use an attribute adjust integer. I just find this is a nice fast way to get this going. And I'm going to use a random and I know that I have 2 variants because I have 3, 0, 1, and 2. And so this will set that up. And if I have a look here, you can see now that I have 3 different flowers. You know, it's kind of hard to see because they all look the same. But if I randomize this, you can see I have different flowers on each of these. And if we go back and we hit render, again, even though it looks wrong in the viewport, it is working here. This one's going to start opening and this one's still closed. So it still respects the rest of the setup. And what's cool is you can just jump in here and just easily change what's going on. Sometimes you just have to refresh. And now we have different flowers on each, and this one's open, this one's closed, so it's respecting it. So it's a very easy workflow. You can come in here and you can change flowers and you can work with them. So this is the way that I love to set up my RS proxies. Of course, if you're not using Redshift but something else, this set primintrinsic is probably the way that you want to go. I know Houdini uses this and will render well with that. I really hope this has been helpful for you. I hope that this has kind of unlocked some ideas on how you can time offset your animations. If you're interested about how I built the rest of the scene, these cool procedural vines, and how I rendered out my proxies and my files, jump onto my Patreon where I'll be covering all this later in the month. Thanks so much. I'll see you next time.